In this question, we're going to have a look at an A-star level question that combines projectiles with Cartesian equations. So in this question, I'm going to make it clear how everything it gives you in a question is actually useful. So we start at a point O, and something is projected with an initial speed u at an angle of theta degrees above the horizontal. So straight off the bat, you should draw a diagram out just to visualize things. At time t after projection, the particle's position is xy. So let's say it ends up at this position where the position vector is xy, where x represents the horizontal distance traveled from point O and y represents the vertical distance traveled from point O. It says write down an expression for x and y at a time t. So you want to write expressions for x and y in terms of t, an equation in terms of t. And it tells you to derive the Cartesian equation from that. Okay, so let's break this part down first and then I'll talk about Cartesian equations later. So what do we know horizontally about a particle in air? Well, we know that acceleration can be assumed to be zero unless it tells you otherwise. That means that, well, you can just use distance equals speed multiplied by time, only when acceleration is zero. So we can say that the horizontal distance that's traveled, x, is equal to the horizontal speed at the start of the motion. How do we find out? Well, what we can do is, I'm just going to get a different color out. We can form our own right angled triangle and we can find the horizontal component of the initial speed, because this initial speed is at an angle. We don't want that angle, we want the horizontal component only. Let's call it, well, because this would be the opposite, this would be the adjacent and this would be hypotenuse. Using SOHCAHTOA and adjacent and hypotenuse, because we want to find the adjacent, we can say cos of the angle is equal to the adjacent that we want to find divided by the hypotenuse of u. Multiply both sides by u and you get that the adjacent is u cos theta. That means that the initial velocity in the horizontal direction is u cos theta. And then multiply that by the time taken to reach that point. Because it wants the equation in terms of t, we're just going to multiply by t, and we're going to say that the horizontal distance that's traveled is ut cos theta. Great. Let's now move on to the vertical part of the motion. Now vertically is where we have to use suvat. We can't assume that acceleration is zero. Instead, it's actually made it a little bit easier for us because it told you, oh sorry, I cut off that part of the question, but it said use the fact that g is 10 throughout the question. Initially it's going upwards, so it's going against gravity, meaning we take minus 10 as the acceleration due to gravity. Now the vertical displacement that's traveled is this distance y. That's what we want to find in an equation, and we want to find it in terms of t. Not only that, but we actually can find the component of the vertical velocity using the fact that its initial speed was u at an angle of theta. So how can we find it? Well, we want to use the opposite and the hypotenuse, and we say that sine of the angle that we want to find is the opposite, sorry, sine of theta, we don't want to really find the angle, is equal to the opposite, which is what we want to find, divided by the hypotenuse, which is given as the speed of u. Multiply both sides by u and you get u sine theta represents the vertical component of this initial speed. So that's u sine theta. Using s, u, a, and t, we can form an equation using the fact that s is equal to ut, which is ut sine theta, multiplied by, plus a half a t squared. A half of minus 10 is minus 5. So we can just write here minus 5 t squared. Perfect. We've now got expressions for x and y at time t. I'm going to rub it out later, but let's just write it out here for when I do rub it out. So x equals ut cos theta and y equals ut sine theta. Sorry if my handwriting's not the best. Minus 5t squared. It then asks you to find a Cartesian equation for the trajectory. Well, a Cartesian equation is an equation where the x and y are written in terms of a different letter, and you want to get rid of that letter so you get an equation only involving x's and y's. The easiest way here is to make t the subject of the simpler equation. So we can make t equal to x over u cos theta, and then substitute that equation for t that you got into the other equation, because that will cancel out with the t's and leaving you with an equation only in terms of x's and y's. In this case, we see that y equals u sine theta multiplied by t, which is x over u cos theta, minus 5 lots of t squared, which is x squared over u squared cos theta. Sorry, x squared over u squared cos squared theta. Great. Now this u cancels out with this u. Sine theta over cos theta is tan theta, so we can essentially simplify this into tan theta multiplied by x, or x tan theta, and then minus 5x squared over u squared cos squared theta. Unfortunately, we can't really simplify that any further, so we just leave it as it is. But because now we've got an expression in terms of only signing x's and y's, that's a Cartesian equation. So let's move that a little bit higher up, just so I can rub out a few things and we can move on to the next part of the question. Perfect. Hopefully that all made sense. Moving on to actually using these expressions now. It says a player in a cricket match throws a ball with a speed of 30 meters per second. Again, let's draw this out. So 30 meters per second to another player who's 45 meters away. So if we draw out the full path of a projectile, that person is 45 meters away. Sorry, I don't know why I did such a bold line. That's 45 meters of horizontal distance. Straight away, that sort of points to me that x now, the horizontal distance traveled, is going to be 45. So let's form an expression. 45 equals u is the initial velocity, as I mentioned before, initial speed. So that's 30 in this case. 30t cos theta. Perfect. Now, this is a very important part of the question that they just snuck in, but it says, assume that the players throw the ball and catch the ball at the same height above the ground. Now, what does that mean? Well, displacement is how far you've traveled from where you start to where you end. And vertically, it's sort of in the same position. It hasn't really moved any distance from start to end in the vertical plane. So that means that the vertical displacement, y, is actually equal to 0. So we can make the expression for y, which is, by the way, you can replace u again with 30. So we can say 30t sine theta minus 5t squared is all equal to 0. Now, I think the best way to go about doing this is, well, what we want to find is, to show that there's two possible trajectories, you want to find two different angles. And you want to show that, okay, it happens at both angles, so there's two different angles that could be an option where it's set off with the speed of 30 meters per second and it travels 45 meters before it reaches the other person. Okay, so let's focus on solving this first. We can factor out t from the right hand side, so we can say t lots of 30 sine theta minus 5t all equals 0. That's equal to 0 either when t equals 0, but that doesn't really help us much. We want to find the time taken for the whole journey, which is this second time, which is when this second bracket equals 0. Now, 30 sine theta minus 5t is equal to 0. When you add 5t to both sides, then you get 5t equals 30 sine theta. You can then divide both sides by 5, and you get t equals 6 sine theta. So when the time taken for the journey is equal to 6 sine theta, that's when this whole sort of process is allowed to happen. That means that we can now put that into the other alternative equation, in this case for the horizontal direction. So we can say that 45 is equal to 30 multiplied by 6 sine theta. So 30, let's write this out. 30 times t, which is 6 sine theta, multiplied by cos theta. Now let's simplify that. 30 times 6 is 180 sine theta cos theta. Divide both sides by 180. 45 over 180 is actually a quarter. Is equal to sine theta cos theta. We're almost at a stage now where we can find the value of theta. The trick here is using a double angle formula. So they've again snuck this in. They like to do that in these A-star questions, sneaking like 2-3 different topics in one. But essentially you can say that since sine 2 theta is equal to 2 sine theta cos theta, if you'd like me to go through why that is, just let me know in the comments and I'll go through double angle formulas. But what that means is that if you divide both sides by 2, so a half sine 2 theta, that'll allow you to replace sine theta cos theta. Why this is useful? Well, we can then solve, which you'll see. So we can say a quarter is equal to a half sine 2 theta cos theta. Instead, a half sine 2 theta, by the way, instead of writing out sine theta cos theta. Now we can just solve for theta by first multiplying both sides by 2 to get rid of the half. So a half is equal to sine 2 theta. And then do the inverse sine of both sides. So 2 theta is equal to the inverse sine of a half. There'll be two values to this, by the way. Do remember that the sine curve. So if I just write out here, it has a maximum value of 1, a minimum of -1. So if it crosses at a half, it crosses at 2 points. And that's essentially why you get two possible trajectories, because of the nature of the sine curve. So the inverse sine of a half, I'm just going to quickly do that on my calculator, is actually equal to 30. To get that second value, you do 180 minus 30, because the nature of the sine curve and the cos curve actually is that it's reflective. So it sort of reflects that 90. So if it's 60 degrees away from 90, 60 degrees away that way as well. So you can just do 90 plus 60 actually as well, which is 150. Now that you've got values of 2 theta, you divide them both by 2 and you get theta is equal to 15 degrees and 75 degrees. So that shows that there's two possible trajectories, because what it shows is that when the angle that is projected from is 15 degrees, or when it's 75 degrees, and it's projected with an initial speed of 30 meters per second, it reaches a person at the same vertical level that's 45 meters away. Very difficult question. There's Cartesian equations, double angle formulas, there's forming expressions of x and y, difficult projectiles, combining horizontal and vertical. So as you can see, this is a very difficult A-star level question. But hopefully it made sense to you guys. Thanks for watching, and yeah, I'll make more A-star level videos. I have a playlist actually, you can have a look at that. It has, I think, like 15 to 20 A-star videos now.